Hi and welcome to this video on SVM algorithm. I am Raghavendra, an expert in AI, ML and data engineering. By the end of this video, you will be able to explain the working of SVM algorithm, find how to obtain the best hyperplane to classify the data points, list different types of kernel transformations applied on nonlinear data. Before we proceed further, let's try to understand what is SVM. SVM is a supervised machine learning algorithm which can be used either for classification or for regression tasks. Here in this video, we are going to look at how SVM can be applied for a classification task. Let's take a scenario given a sample data set with equal proportion of males and females. The data set comprises of two features, height of an individual and hair length. The task here is based on the above features of height and hair length. We would need to classify if a person is male or a female. And by the way, this is a labeled data. The graph of these two features are depicted as shown. The blue circles represent females and the green squares represent males. From this graph, we infer that males have an average height and females have longer hair. If we have an individual with height 180 centimeters and hair length 4 centimeters, our best guess will be to classify this individual as a male. Let's now understand what are support vectors and what is support vector machine. Support vectors are coordinates of an individual observation. For instance, the coordinate 45, 150 is a support vector which corresponds to that of a female. Likewise, a support vector 180, 10 corresponds to a support vector of that of a male. Support vector machine is a frontier or a hyperplane which perfectly separates the two classes. Now the question is there just one hyperplane between the two classes? The answer is no. There could be many hyperplanes between the two classes, and which could be used for classifying the data points. So below are the three possible hyperplanes, but there could be many such hyperplanes between two classes of data points. And now the question is, how do we find the best support vector machine or the best hyperplane which best separates the two classes? To answer this question and to find the best hyperplane, what we do is we find the distance of each hyperplane from the farthest support vector belonging to each class. So here is the farthest support vector of this class. And let's consider this support vector as the farthest support vector of another class. So we find the distance of each hyperplane from the farthest support vector belonging to each class. So distances are being computed between the hyperplane and the farthest support vectors of each class. So this is called as the margin. Once the margins for all the hyperplanes are computed, the algorithm finds the hyperplane with the maximum margin from the farthest support vector of each class. So here, if you look at the hyperplane given in yellow, it is the hyperplane with the maximum margin from the farthest support vector of both the classes. The goal of SVM is to obtain the hyperplane with the maximum margin from the farthest support vector of both the classes, and this hyperplane will be used for classifying the data points. So far, our discussion of identifying the best hyperplane holds true if our data is linear. So let's consider our data something like this as shown, where our data is non-linear. Suppose our data set is nonlinear, wherein we cannot draw a straight line to classify the data points. In such scenarios, SVM algorithm will map these vectors to a higher dimensional plane so that they can get segregated from each other. This is called as a kernel trick or kernel transformation. So we have our input data in this nonlinear format. A kind of kernel transformation is applied to this nonlinear data so that the data becomes linearly separable by drawing a hyperplane. So there are different types of kernel transformations. Some of them are being listed over here. It could be a polynomial kernel or a Gaussian kernel, Gaussian radial basis function kernel, Laplace radial basis function kernel, and the sigmoid kernel. The key takeaways from this video are: support vector machine is a frontier or a hyperplane which perfectly separates the two classes. SVM algorithm trains the model to obtain the best hyperplane with the maximum margin from the farthest support vector of each class. SVM algorithm will map nonlinear data into a higher dimensional plane so that they get segregated from each of them. So this is called as the kernel transformation. Thank you. Thanks for watching this video.